The last couple of videos were all about propositions and the propositional forms that they share, their instances of. Today we're going to talk about arguments and argument forms, and they're going to be very similar to the propositions and propositional forms, but still worth a peek. Take argument one here. P, if P then R, therefore R. Now if I were to take the P's and replace them with a well-formed formula variable alpha, and I took the R's and I replaced them with the well-formed formula variable beta, now all of a sudden I would no longer have basic propositions in my argument, right? The P's and the R's, they're gone. And those P's and the R's, remember, those were the things with content. Those were the things that had content, and we built the rest of our propositions and then ultimately our whole argument out of. So now that they're gone, instead, these well-formed formula variables are just placeholders for basic propositions or for other kinds of propositions as well. But they don't have any content themselves. Now we just have open spots where our basic propositions used to be. That's not the only way to make an argument form, and we'll get to that kind of stuff in just a second here. But this is an argument form here. What exactly makes this alpha, if alpha then beta, therefore beta, what makes this an argument form? Well, we actually have to meet the same criteria that we had to meet for propositional forms, only now instead of applying to just one proposition, we're going to apply them to all the premises and the conclusion in the argument. So for example, our first criterion was that it must be a well-formed formula. And when I look at this now, my argument is going to have nothing but well-formed formulae, right? All the premises and the conclusion will have to be well-formed formulae. So alpha, well-formed formula. If alpha then beta, well-formed formula, and then beta itself, well-formed formula. An example of something that doesn't meet this criterion and therefore is not an argument form would be something like this. Alpha, alpha beta arrow, therefore beta. When I look at premise 2, that second proposition there, I notice that that's not a well-formed formula. So long as even one of these guys is not a well-formed formula, the thing is not an argument form. Our second criterion was that it must have at least one well-formed formula variable to be a propositional form. To be an argument form, each premise and the conclusion are all going to have at least one well-formed formula variable as well. So in my example here, the first premise has that well-formed formula variable alpha. The second one has alpha and beta. The third one has, or the conclusion has beta. So each one of these guys has got a well-formed formula variable, check. An example of something that doesn't meet this criterion and therefore is not an argument form. If I look back at the regular argument, I had P, if P then R, therefore R. Well, that has no well-formed formula variables at all, so that is not an argument form. It's just an argument in that case. But if even one of these premises or the conclusion is lacking a well-formed formula variable, then the whole argument is not an argument form. So for example, if I had alpha, if P then R, therefore beta, that wouldn't be an argument form because premise 2 there does not have any well-formed formula variables. And then finally, our third criterion is that we can't have any basic propositions at all. Remember, those are the things with content. We want to avoid having content when we're looking at the forms of the arguments because we want to be looking just at that structure, just at the form, and not at any specific content. So in this argument, we have alpha, if alpha then beta, therefore beta. There are no basic propositions in there. We've abstracted from all content. Good. An example of something that doesn't meet that criterion, if I had alpha, if P then beta, therefore beta, just having that one P there introduces some kind of content into this argument, so it voids this from being an argument form. Also, the reminders that we talked about in the last two videos when we're talking about propositional forms and really how well-formed formula variables apply, those apply here in the argument forms as well. So our first reminder was that the well-formed formula variable can stand for any sized well-formed formula. The basic proposition is the smallest well-formed formula, but any component of a larger well-formed formula that is also a well-formed formula, that counts. We can throw a well-formed formula variable in for that, to substitute in for that, or even the entire well-formed formula itself. So for example, I have here P, if P then R, therefore R. I can make P alpha, I can substitute it in there, and then I can replace if P then R for beta. So now notice I'm not taking into account the fact that there are two basic propositions in there with a connective there. I'm just sort of totally doing away with that and putting in that beta. And now I'm actually going to have to change tactics for my conclusion here and say therefore gamma. Well, this is an argument form that our argument is an instance of. Argument 1 here is an instance of this form. Remember, our arguments, just like our propositions, will be instances probably of several forms. So here's one of them. Our second reminder 2a, was that different well-formed formula variables can actually replace the same well-formed formula. So for example, I can have in here P, if P then R, therefore R. I can have that first P be alpha, the second P beta, the R in the second premise be gamma, and the second R be delta. Now, even though in my argument I have two P's and two R's, now all of a sudden I have four well-formed formula variables that are replacing those, but that's okay. Remember, I said you can think about this just like algebra, where you have x plus y, and you could substitute in 3 for x and for y. That's okay. There's no confusion in that. What you can't do is, reminder 2b here, remember that you can't take the same well-formed formula variable and replace it with different well-formed formulae. So for example, you can't have alpha, if alpha then alpha, therefore alpha. Well, every time I have an alpha, I should be able to plug in the exact same thing and not have to wonder, well, which one do I want to put in here for alpha? Which one do I want to substitute? Again, if you want to think of it just like algebra, I wouldn't want to have x plus x and then substitute a 3 in for the first x and a 4 in for the second x. Then all of a sudden we've lost the continuity that we had with that same variable. And the same thing with these well-formed formula variables. We want to treat them just like those x's and keep them constant when we're replacing them, but it's okay to replace different well-formed formula variables with the same well-formed formula. But now what about going the other way? We already have our argument form. How do we go from our argument form and generate new instances of that form, new arguments that are instances of that argument form? We would basically start replacing well-formed formula variables with well-formed formulas. So, for example, instead of alpha here, I'm going to replace the alphas with q's, and let's say I'll replace the betas with s's. I would now have q, if q then s, therefore s. So this is argument 2 here. Arguments 1 and 2 both share the same argument form, which is that alpha, if alpha then beta, therefore beta, which we call modus ponens. But just like before, we have to remember those 3 reminders. So reminder 1 was that a well-formed formula variable can be replaced by any sized well-formed formula. So for example, let me replace my alphas with an if p then q and my beta with r. So now instead of alpha in that first premise, I would have if p then q. And then in premise 2, I would put if p then q, then r, and finally in the conclusion would be therefore r. So notice this has gotten bigger. Although this argument, we'll call argument 3, although it shares the same argument form as arguments 1 and 2, hopefully you can see that it's also an instance of different argument forms that arguments 1 and 2 are not instances of. So you are allowed to do this. You are allowed to take a well-formed formula variable and replace it with large well-formed formulas. Reminder 2a was that I could take different well-formed formula variables and replace them with the same well-formed formula. So for example, we have alpha, if alpha then beta, therefore beta. Let me make alpha p and also replace beta with p. You're allowed to do that. So now our new argument would read p, if p then p, therefore p. We'll call this argument 4, and argument 4 also shares the form of modus ponens with arguments 1 through 3, but hopefully you can also see that this is an instance of an additional form, which would be something like alpha, if alpha then alpha, therefore alpha, which arguments 1, 2, and 3 are not instances of. And finally, reminder 2b was that we can't take the same well-formed formula variable and replace it with different well-formed formulae. I'm so sorry. So the formulas versus formulae is driving me freaking crazy. And I read in different books, people use different words for it. So just so you know, if you're hearing me and you're just like, dude, you're starting to make me upset, I apologize. It makes myself upset. I'm never sure, which one am I supposed to say? So regardless, we're going to continue on, and just know that I'm going to be flipping around because I hate that. In any case, so take argument 5 here. Let's say I had P, if Q then R, therefore S. Now, this is not an instance of the modus ponens. Why? Because I wasn't consistent in replacing that alpha, first of all. I replaced that alpha in premise 1 with a P, and in premise 2, I replaced alpha with a Q. And in premise 2, I replaced beta with an R, but in the conclusion, I replaced beta with an S. So I wasn't being consistent in which well-formed formulas that I was replacing my well-formed formula variables with. So this is not an instance of that argument form. And before we get on to our exercises, once again, just like in the last proposition form video, I talked about a little bit of terminology. I said that propositions are instances of their proposition forms, and two propositions would share the same propositional form. Same thing here. We'll say that an argument is an instance of its argument form, and we'll say that two arguments share the same argument form, and for the same exact reason. And something we saw earlier in this video, which is that two arguments can share one form, but not share other forms. So for example, that P, if P then Q, therefore P, that was argument 1. Argument 4 was P, if P then P, therefore P. They both share the modus ponens form, but argument 4 also has that form alpha, if alpha then alpha, therefore alpha, which argument 1 doesn't have. So we don't want to tie them down to one specific argument form by saying that they are of a specific form. We'll just say that they're instances of the specific forms. With that said, let's move on to 5.3.1 exercises, where we're given some arguments here. And for each argument, we're asked to identify 4 argument forms that it's an instance of. Our first argument here is it's not the case that if R, then Q, therefore either R or if R, then Q. Now, probably the most obvious thing to do for each one of these is to take a basic proposition and identify it with a well-formed formula variable and just keep it isomorphic. So for example, here I'll have alpha, and I'll make it R, and beta, I'll make it Q. And then my new argument form here will be, it's not the case that if alpha, then beta. And then therefore alpha or if alpha, then beta. Well, let's go ahead and move on to our second form. Not the most obvious, but probably the easiest thing to do would be to take each premise and the conclusion and identify each one with a different well-formed formula variable. So here I've identified premise 1 with alpha and the conclusion with beta. So my argument now will read alpha, therefore beta. Super easy, not a whole lot of information we get from that. In fact, this is probably the most obtuse form that we could have to generate here. But it works. This is an instance of that argument form. But now remember that we had that reminder 2a that said we could have different well-formed formula variables that represent or are substituted in for the same well-formed formula. So here what I'm going to do is I'm going to make alpha with an R and beta Q, and now gamma also with an R every once in a while. So now my new argument form here is it's not the case that if alpha, then gamma, then beta, therefore either alpha or if alpha, then beta. So notice I put that gamma in for just one of those alphas, and I could have chosen any one of them. I could have done it for multiple of them. I could have done it any way that I want to, and each one of those would be a different argument form that this is an instance of. So that is remembering 2a. Finally, let's notice here that we have that if R, then Q, in both the premise and the conclusion. And now this time we'll make R be alpha and beta be if R, then Q. And so my new argument form reads, it's not the case that if alpha, then beta, therefore either alpha or beta. And now this argument form is interesting because remember that when you have a negation of a conditional, like if A, then B, or in this case, if alpha, then beta, then that only happens when the antecedent is true and the consequent is false. So if it's not the case that if alpha, then beta, that means that alpha is true and beta is false. And now look at that conclusion there. That conclusion says either alpha is true or beta is true. Well, we know that alpha is true given the premise here, so we know that this conclusion is also true. And it's a little confusing here because that beta, it says alpha or beta, and we know beta is false. That's okay, right? All this conclusion is saying, all a disjunction says is that at least one of those two things are true. And sure enough, we know that alpha is going to be true. But really what's interesting here is that before I did this, before I identified this argument form, I didn't realize that it was like this. I didn't realize it was so simple. It wasn't until I actually identified the argument form that I could start thinking about it a little more clearly. So here's one great benefit for breaking these arguments, as big as they might be, down into one of their simpler argument forms. Argument 2 is, if P and Q, then Q. It's not the case that Q, therefore, it's not the case that P and Q. Again, the most obvious thing to do here is to identify a well-formed formula variable with a basic proposition and just keep it isomorphic. So in this case, I'll say that I'll make alpha replaceable by P and beta replaced by Q. And then my new argument form here, or the argument form that this is an instance of, will be if alpha and beta, then beta. It's not the case that beta, therefore it's not the case that alpha and beta. But again, the easiest one would be to just take each proposition, the premises and the conclusion, and identify each one of them with a different well-formed formula variable. So I'll identify premise 1 with alpha, premise 2 with beta, conclusion with gamma, and then I have alpha, beta, therefore gamma. Not super interesting there. One thing I could do is I could take that not Q and I can identify that with gamma. So my argument form, if I look at things that way, is going to be if alpha and beta, then beta, gamma, therefore it's not the case that alpha and beta. And of course, when I look at that, I realize, oh, that's not really what I want, right? That doesn't really give me any good information here. It doesn't really help me all that much. So let's instead notice that we have P and Q in there, and it shows up a couple of times. So we'll make alpha P and Q and beta Q. Now let's see what happens. My argument form will be if alpha then beta, it's not the case that beta, therefore it's not the case that alpha. And actually, this is a famous argument form called modus tollens. Modus tollens is you have a conditional, if A then B, and then what that means then, or let's just use this if alpha then beta, even though this isn't really, this is a propositional form, not an actual proposition. But we'll just use that because that's what we're using right now. So if alpha then beta, what I mean by that is that if I have alpha, I gotta have beta, right? Well, so let's pretend I don't have beta like premise 2 here says. If I don't have beta, well, I must not have alpha either, right? Because if I had alpha, I had to have beta. So it must be the case that if I don't have beta, that I can have alpha. That's modus tollens here. And now I realize that this argument that I thought was so complex before is just a modus tollens. And I know how to deal with those. And I know you don't know how to deal with those just yet necessarily, but that's going to be coming up very soon, so no problem. Number 3 is if not Q, then if R then S, not Q, therefore if R then S. Now, again, let's start off with our obvious one where we'll just make them isomorphic. We'll make alpha identical to Q, beta, R, and then gamma S. And now our new form will look just like our argument, except for replacing a few things. And it'll look like if not alpha, then if beta, then gamma. Not alpha, therefore, if beta, then gamma. And I know what you're thinking. The next thing he's going to do is just replace, entire propositions, but that's so easy and that it's not very interesting to you. So let's not do that anymore. Instead, let's do this. I noticed that I have not Q in a couple of places. That might be interesting. Let's see what happens if I replace those together. So we'll make alpha not Q now. So now when we have alpha not Q, beta is R and gamma is S, our new argument form will be if alpha, then if beta, then gamma, alpha, therefore if beta, then gamma. And that's a little bit cleaner, right? It's a little bit more obvious to see what's going on here. But now I also see that if R then S a couple of times there. Well, let's make beta if R then S, and we'll make alpha Q, and then we'll have our following argument form. If not alpha, then beta, not alpha, therefore beta. That's a lot more clean, right? Now we can put together both strategies. Let's make not Q into alpha, and if R, then S to beta, and my argument form will be if alpha, then beta, alpha, therefore beta, and that's our favorite guy, modus ponens, that we saw earlier on. This is another argument form that's very famous, very easy to use. Whereas before it was super complex, I had a bunch of letters all over the place. Now I see it shares one argument form that's very simple that I know works. I know that this one is going to help me out here. Finally, argument 4 here if P then not Q, or if not Q then P. It's not the case that if not Q then P, therefore if P then not Q. We'll start off with the obvious one once again, and we'll make alpha P's and betas Q's and our argument form. I had to kind of smush them together here, but it looks as follows. I'm just going to read off of the thing. I'm trying to make it as if I memorized all these, and I clearly did not. If alpha then not beta, or if not beta then alpha. It's not the case that if not beta then alpha, therefore if alpha then not beta. That's still a whole hog of a mess. So let's see what we can do now. Let's make instead alpha to be P and beta to be not Q, because we see a bunch of not Q's in here. So this is going to clean things up a little bit more. And now we'll have if alpha then beta, or if beta then alpha. It's not the case that if beta then alpha, therefore if alpha then beta. That's a lot nicer. I see a lot more stuff going on there. Now instead we'll make alpha to be P, beta to be not Q, but let's make gamma to be if not Q, then P. Let's see what happens there. We'll have if alpha then beta or gamma. It's not the case that gamma, therefore if alpha then beta. Okay, that's not too bad. But now let's go for the gusto, and we'll make alpha to be if P then not Q, and beta to be if not Q then P. And again, I don't know if you caught on to this, because I guess I didn't really realize I was doing this until I made this video, but one of the reason I'm picking these specific ones is because I see them show up a couple of times in different places. And I want to see, oh, well, what happens if I just sort of smush those guys together so I don't have to look at all the extra stuff in there. And when I do that, now I have either alpha or beta. It's not the case that beta, therefore alpha. And this is a famous form of argument known as a disjunctive syllogism. Remember that a disjunction means that at least one of these two guys are true. Either alpha is true or beta is true at least. Possibly both, but at least one of them. And then in premise 2 here, it says beta is not true. Well, if at least one of these two guys are true and beta is not the one, then it's got to be alpha, right? So now that I'm looking at this, I can see, oh yeah, this is a disjunctive syllogism. I like these guys. I know these guys work. So interestingly enough, once you start actually, looking at argument forms, it clarifies what you're working with. It makes it a lot easier. In any case, that's all we have for 5.3. For next time, and let me just warn you, it's going to be a little bit longer. Go ahead and read 5.4 and 5.5 and do the exercises for both of those, 5.4.1, 5.5.1. It will be longer. I'm going to be trying to introduce things a little bit differently than Smith does, not because he doesn't do a good job, just because once we start to work with validity with these forms, things start to get a little bit funky, a little bit hard to understand. It's good to see it in different ways. So I'm going to teach it a little bit different than Smith does. Again, not because he does a poor job, but because I think approaching it from a different angle will be good. So read those two together. We'll go over them in the next video, and I will see you there.